just saying that every year I try to build something new that the year before was difficult to build. And one of the things that normally is limiting the interactivity of application is using the HTTP protocol to communicate between a browser and a backend, because the HTTP protocol is now designed to have only the client starting a request and then the server replies back. But a few years ago, the WebSocket protocol was standardized. And what happens is that during a normal HTTP communication, the client can request to the server to upgrade the communication to a WebSocket. The server can accept, and if they are both right, then they can establish a bidirectional communication channel that is a WebSocket, where both the client and the server can send information to the other party. So it's much, much faster. There's also much less overhead because there's all those headers of the HTTP protocol are not there. So it's very fast, very few bytes on the wire. And so I decided, OK, let's play with this technology. What can I build? So first of all, what technology I want to use. So using WebSockets with serverless was already possible. There were, for example, if you use AWS IoT, it's a platform for internet computing that Ben knows very well. And you can use it without any device. You can connect browsers, for example, and use the WebSocket protocol to communicate on top of MQTT. MQTT is quite a heavy protocol because it's a publish and subscribe protocol. So it's not really what I wanted, because I wanted to have access to low-level WebSockets. Another option is to use AppSync. AppSync is a GraphQL interface to cloud backend. So GraphQL has lots of features. One of the interesting features is subscriptions. So with GraphQL, you can subscribe to some data. And if this data is updated, you can get a real-time notification. And this works using, again, WebSockets. But again, it was too much. I really wanted to have low-level access to WebSocket protocol. And that's what we added at the end of last year. It's now possible with the API gateway to use WebSockets. And you can use WebSockets in an event-driven way. So normally, the browser connects to the API gateway using WebSockets. This creates a connection ID. And this is a stateful connection that is managed by the API gateway and the client. But your business logic, your backend, doesn't have to be connected all the time. It just reacts to events like usual functions. So when you get connected, the API gateway sends a connect event, and you can use a function to react to this connection. For example, to store the connection ID of the client. If there is a clean disconnection, again, there is a disconnect event. Not all disconnections are clean, so you may expect that you don't always get a disconnection, even if the client gets away from your application. If you assume that the payload that you exchange using WebSocket is a JSON document, you can create route keys based on the value of a specific attribute in your JSON document. And you can route this, depending on the value of the route key, this message to different backend functions. So in this way, you can scale to multiple functions. And then you can set up a default function that gets all the other messages that are not routed by an explicit key. And in this way, you can create an event-driven architecture with a stateful protocol like WebSockets. And all those functions can do an HTTP post back to the API gateway to send a message to a specific connection ID. So you need to know the ID of the client, and then they can say, send this message back to the client. In this way, you can process some information and send information back. So OK, I have the technology. What should I build? And so when you look at all the literature of WebSockets from probably 8, 9 years ago, this mandatory example is a chat. Everywhere you find, OK, let's build a chat with WebSockets. So OK, let's do that. But maybe I can do something a little bit more interesting. So one thing that interests me a lot as an evangelist, where I mix communication and technology, is communication. Because I see that especially online, not in-person communication is really hard. It's very easy to see flames starting up, a comment that is taken badly, and then people start fighting with comments, horrible things written in comments online. So maybe I can do something to improve this so that my demo is not just useless. And one thing that I thought is maybe I can use machine learning, because machine learning is still quite a broad thing to use. But on top of the infrastructure, the open source frameworks like PyTorch and TensorFlow, on top of the platform that we can use to create and train big machine learning models, there are those very easy to use application services that can analyze a picture, can analyze a piece of text, and give you some feedback very quickly. And those are truly serverless, because you don't need to manage servers, you need even to manage the machine learning model. You just send some content and get a feedback. So I thought maybe this part here can be useful to create a chat that is a little bit better than the normal chat. So I created this positive chat. So the idea of this positive chat is, first of all, to avoid negative sentiment. So if you write something negative, it's rejected, and they tell you, hey, maybe you can rephrase this in a better way. So imagine to use this in a team to exchange information. Every comment should be put into a constructive, positive way. And also, another thing that I was thinking of is language. Language is important, but not everybody is English first language. As you can hear from my accent, I'm actually Italian. So my experience is that when you have a distributed team, people that doesn't speak English well as others, normally they feel that it's more difficult to participate, to express their ideas. So maybe I can automatically translate messages so that everybody can participate in the same way to the team. And then also I can use machine learning to extract topics from the conversation. So if you are in a chat room that has a specific name, maybe people is actually talking about other things. So you want to know effectively what are the topics discussed in this chat room. And then other things that are still in the build are extending this also to images. Now I can analyze an image. You can, of course, moderate content with images, understand if an image is appropriate or not for a chat. But you can also, for example, describe the content of an image automatically with machine learning. So you can see which objects, which expression, which people is in the picture, so that if someone is visually impaired, they can participate to the chat and get a description of the text of the content of an image. And maybe just if someone wants to interact via voice using a platform like Amazon Alexa, they can still understand what's inside a picture that has been shared. And then you can also use machine learning to anonymize faces. This is a requirement in lots of countries. So maybe if someone looks like it is less than 18 or 21 years old, I can cover his face with an emoticon, and I can maybe use the right expression depending on the emotion of the face of the person. This is actually one of the first use cases that I saw being built with Amazon Recognition when we launched it in 2016, covering faces with the appropriate emoticon based on the emotion of the person. So how can you build it? So I start working a little bit. So first of all, I put all my static assets, so the HTML, the JavaScript running on the client, on the browser, in an S3 bucket. The client downloads this, then runs the JavaScript client side. This does to connect to the API gateway using the WebSocket protocol. And then to simplify the configuration, I send all the information to a single Lambda function. I only have the default Lambda function configured here. So the struggle of deciding between one or more functions, it was easy for me because I really wanted to build something small and easy here. So single function gets everything, and then it can call machine learning services like comprehend to analyze the text and understand which is the language, the dominant language of a message. Is this written in English, in French, or in Japanese? What is the sentiment of this sentence? Is it positive or is it negative? And then I can translate to the language that people can choose to receive a message. So I want to receive everything in English or in French or in Italian. Then as a database, I'm using DynamoDB, that since we launched the on-demand option is truly serverless, I would say. And with DynamoDB, I have 3 tables. One is to keep the connections. As I said, any client connects and gets an ID. And when they connect, I want to know in which room they are connected. And then I have to keep this link between room and connected clients. So this is the connections table. Then I have a conversations table where I store all the history of the conversations, so that if you connect, you get all the old messages. And then I have a topics table where I store the most commented topics in that chat room, so that I can create a tag cloud of what is being discussed here. And things that I have to implement is authentication, small details, and also the image analytics that I was presenting before is still not there, is still to be refined. So to define my application, as Ben already said, always try to define your infrastructure as code in the cloud. And luckily, I didn't use the CDK for Ben, so I used the plain old AWS SAM. So this is a JSON syntax. And with few lines of code, you can define the function, the role, the API gateway, the DynamoDB tables that I need. And one tip that I would like to show is if you one thing that I find is that building permissions in the cloud can be difficult for people starting because permissions are not easy to understand when you need to give access, for example, to a database table or to an S3 bucket. So with SAM, we created these policy templates. They were released a couple of years ago, so not at the beginning of SAM, so you may have missed them. So if you want to, for example, to pull messages from a queue, or you want to have read or write access to a DynamoDB table, you can use these policy templates. They bake all the AWS permissions for you, so it's much, much easier and faster to start with, and they're well written on our side. And then the SAM tool that is open source has also a command line interface that you can use to initialize your code, run your function locally to do your quick debugging. You can validate, build, and deploy your functions in the cloud. And these 4 commands actually are really well suited to be part of your CI/CD pipeline. For example, we have also a plugin for Jenkins, or you can use tools like CodePipeline that we provide. So in this way, you can really automate, and when you commit your code, everything goes to production or to a test environment very quickly. And then one other tip here is that SAM allows you also to look into the log of a function, and you can also tail the logs of a function using the -t option. So if you create your first function, you can tail the logs and get the logs locally. It can really help you understand what is happening in the cloud and debug what you're building. And you can also publish your application and share it within your AWS account or with everybody if you want, using the serverless application repository. This is a quite interesting approach. So let's see if this works. So I'm trying a demo. So the network is not super fast here, but I would like to try. So this is the link. You can scan it, or if you're not lazy as me, you can even type it. I redeployed everything in Singapore during the night, so it should work. But it's really a fresh installation. So I leave a few seconds more for people to connect. OK. Oops. So you should find something like this, where since there is no authentication, you just choose your username, and then you choose the language you want to receive your message, and then you start. And this is some content that I put, I think, this morning relatively early. And I start to see stuff happening here. So let's see if this works. For example, let's say something that everybody in this room is thinking about. So this is an horrible demo. So if I send this, I find this message here that says, please find a better way to express this. And actually, you didn't receive this message. So it found that the content is negative. And then if you want, you can say, OK, let's put everything in French. French is always much better. And you see everything, it looks more interesting and more romantic now. Or if you want, you can choose something more interesting like Japanese, and let's translate everything in Japanese. So actually what I do, the language you choose is the language that you receive all your messages, but you can write in any language, because when you send a message, I analyze the language of that specific message. So you can write in English and receive your message in French. So let's remove this before people try. OK, I see a drop table, and that's quite normal. So you can test the robustness of the code online. This is an open source application. It's in my GitHub account. And actually, the reason why I wanted to show this application is not because I'm a great developer, but because it's very small. So I built this with all the machine learning features and everything, and it's 460 lines of code. And 50 lines are just to avoid SQL and JavaScript injection on the browser. So the business logic is 400 lines of code, 200 in the front end and 200 in the back end. So this is the power of serverless. In a few hours of work, you can build this. And then if you want, you can validate it, transform it into a product, add all the features that you want. But it's so easy to start and build. And just to give you an idea of the code, so I have the code here. This is the backend code. So, this is the front-end code, so the JavaScript running in the browser. This is I decided to not use any heavy framework like React or Vue.js. Vue.js is not that heavy, but the idea was to really provide something easy to understand. So this is plain JavaScript. So here I create a WebSocket, and then when you have a connection with the WebSocket, you can react to events. So if you will look at the code, both the code running in the client and both the Lambda function are event-driven. They react to events that are exchanged between them. So when the connection is open, I send an initialization message to say, hey, this is a new client. He wants to connect to this room, and he wants to receive messages with this language. Then when a new message arrives, I just do some basic HTML to display the message. And then if the connection is closed, this is a tip for people playing with WebSockets. If the error code from the closure is different than 1000, this is a magic number, it means that the connection has not been explicitly closed by the client, so probably has been closed by a timeout, maybe if you use a mobile client. So you can just check if the navigator is online, so you still have network, you can just reconnect and reinitialize everything. So this is very useful for using this in a browser running in a tablet, because it will automatically reconnect if there is a timeout. So this is most of the code running on the client. And if I go on the Lambda function, I have something similar. I receive events, so it's very similar and symmetric. I have the connection event, the disconnect event, the message. If I receive a message, I process the message. And if I go into the process message, I look into the action of the message. If it's the initialization message, the first message that the client sends when you connect, I initialize the connection, writing the information on the database to say, hey, this client is connected to this room. And then I send all the messages to the client so that it gets the content of the room. If it's just one message during the chat, I analyze the message using machine learning services. Then if the message is rejected, I reject the message, saying, hey, as you saw, this is probably not the best thing to express in this chat. And if the message is OK, I just send the message to the room, and it's persisted. So very simple, and then there's a little bit more boiler code. But it's really as easy as that. So this is so easy to build an application that probably if I have to build this 5 years ago, it would require, I don't know, 20 people working for a month, if not more. So when I build this, I'll start to reflect, what means to build a product with serverless? Is it different, or is it the same? It's just faster. One thing that I think is affected is the team. So I think we should really reflect on the fact on what is the perfect team to build a software application, and especially a serverless application. So I think that you need less people, because it's really focused on the features that you want to build. And we in Amazon have this approach that our teams are independent. They have the full ownership of what they build, and they follow everything from development to test to production. And they keep in touch with their customer as much as possible. So if I have to do this for every product, probably one could say, OK, the best thing to do is to have a very large product team. I take 100 people, and they can do development, test, and production deployment. But that doesn't work. That doesn't work because the size of the team affects the way we communicate. So for example, if we take a team of 3 people, how many communication paths do we have between 3 people? Without considering the direction. It's 3, very easy. If I have 5 people, how many communication paths I have? It's 10. And it grows with the square of the number of the people. And I'm not considering directions here. So that means if you have 10 people, you have 45 communication paths. It's a team of 10 people can't communicate peer-to-peer. They will automatically create subgroups and subteams that you don't know about. So it doesn't work. You need that small team. And that's why serverless helps, because a small team is much more productive than with other technologies. And when you create this small team, we call them 2-pizza team. And by the way, these are American pizza. These are not Italian pizza, not because of the look, but because an Italian pizza normally is for 1 person. So 2-pizza team will be just 2 people at the most. So normally the sweet spot is 3 to 5 people. That's probably the best sweet spot that you can get. 6, 7 people starts to be complex. More than 7 people is not a team. You should probably split into what you're building. And the idea is, OK, let's build this small pizza team. How do I choose the skill into this small team of 3, 5 people? So to define this, it's better to understand what you are trying to do with software development. So normally there are 2 kinds of tasks that we can do as people. Some tasks are separable. So if I need to move this, and some chairs maybe from this side of the room to the other side of the room, if I'm alone, it will take some time. If we're 3 people, we can split the task and be much faster. But if we build a software application, this is a complex task. You can really split things easily into isolated subtasks. Everything needs to collaborate together, and everybody provides a different perspective and different solutions to the problem you're solving. This is a complex task. So how can I choose the skill of this small 2-pizza team in the best way? So let's do a model. People that knows me on Twitter knows that I like mathematical models is something that I think we should apply more to find solutions. And this is a some people say that all models are wrong, but some are useful. So I hope this is one of those. Let's create a model of cognitive tools. So let's simplify and say, for example, here we have Adam. Adam has 5 abilities, and I call these 5 abilities A, B, C, D, and E. And then these letters can represent whatever you want. So in this case, we are talking about software development. So maybe A is mobile development or backend development. So Adam is quite a smart guy because he does lots of stuff doing analytics in SQL and so on. But let's think that these are 5 unique abilities that he has. Then I take these 3 people. Each one has their own abilities. And I'm the manager. I have to create the best team possible out of 2 people out of these 3 people. What should I do? So the normal approach is, OK, I take the best people and I create the best team. So I take the best people that has more abilities, but there's lots of overlap here. They know basically almost the same things. So the unique number of abilities that I have is 6. So these are the 6 different directions in which they can look at a problem and find possible solutions. If I take the 2 worst people and I create a team, there's less overlap, and they provide me 7 different abilities. So maybe some of them can look at differently how I work in the backend or in the front end, and maybe they can find a better solution. This is a simple model of the diversity bosons, and it's one of the reasons why we need diversity in IT and in other things that we do, because diversity provides different perspectives and can help us find solutions that otherwise are impossible to see to a traditional team. And this is not easy in general, because one problem for diversity is hiring managers. So if I'm hiring for my team, I will look into the people, the things that I know, and I will hire people that are either like me or a subset of what I know. And then at the end, I end up in this situation where the best person in the team is the team leader, and there's no diversity, and nobody can provide a constructive feedback on top of what the leader already knows. And this is even worse in some fields where things must be learned in order. So if I create a team that does image recognition using deep learning, all the people probably they need to know deep learning with a focus on image analytics. They need to know machine learning. They need to know linear algebra. And since they have to learn these things in order, it's very difficult to have a different background. So this is another big problem for specific fields. And one is really to be creative here. So I've been looking for different universities already can create a different perspective in solving the problem, looking, for example, in even something that is not really related. So in a team of people doing deep learning, I hire someone that is doing a Bayesian approach, more statistical oriented, because he can provide me a different perspective in finding the solution. So this is something we should really think of, because otherwise we always see the same problem and the same solutions. So when you create this small team using diversity to get the most possible perspective, should I use this team for the rest of their life, or should I change the team? So luckily, someone did an interesting study, because at the end, solving a software problem is a problem of creativity. It's being creative and finding new solutions. So someone studied one of the most creative environments in the world, that is Broadway, where in New York, they create these musicals. And what they did, they looked into the work of 2,000 people for 40 years. They created 400 or 500 musicals. And they look into the reviews and the revenues of these musicals, and then they study the dynamic of the teams. This is normally an example of small word networks, when you have these small interaction networks between relatively small teams. And then they find out, they created a parameter that they call Q, and this parameter it shows how often a team worked together before. So a team with a small Q, they never worked before, and they created some musical from scratch. A team with a very high Q, they worked together a lot, and then they created some musical. And then they looked for the correlation between Q, this parameter, and the reviews and revenues that are strictly correlated for musicals. So what do you think happened when they did this study? So who thinks here that a team with a very low queue, so they never worked together a lot before, gets the best reviews and the best revenues? Okay. Who thinks that the team with the highest queue, so they work together a lot, gets the best reviews and the best revenues? Who thinks that an average value of queue gives the best results? Exactly. That's why I put it at the end, so that few people still didn't raise their hand before. So actually, as you can see, a small value of queue, it really gives poor performance. So you need to work together a lot. But after some time, you fall into habit. You start to repeat the same solutions again and again. You can't look into different perspectives. So you need some dynamic in the team that you create. So to be successful in software today, I really think that we need to write less code and be serverless. We need to give teams ownership and autonomy. And this team should be small to not create a communication overhead when they work. We should maximize the different abilities, looking into diversity to get this bonus that diversity can provide to us. And you should mix new and existing relationships so that we always keep this team alive and looking for new and possible solutions. Thank you.